Hello everyone. Today I've got a little holiday project for you. Just something that I was coding in a bit of spare time that I had. I thought you might like it, and also it might be interesting to see some of the techniques here as well. I've called it Fyne Pet. Maybe you can see where this is going already. If you've ever owned a tamagotchi, then this might seem familiar. It is a simulation of a very small electronic toy from, I guess, the 90s. It has a little bit of an animation based on an LCD display, and there's 3 buttons at the bottom. They're not wired into anything just now. The project's just got started, but it's enough here that I thought I'd show you how we built it. So let me just open up the code. So here we are in the project. There's a few Go files and some PNGs. Nothing too complex, but I'll just step through it. To see how it's rendered, I'll show you the PNG files first. This one called egg is the outline of the shell. It has a sort of transparent cutout there for the screen. The background file doesn't look like much of a background. It's just providing the background element to the screen, and we're going to draw the animation between the background and the foreground, making use of that transparency. That's really all the graphics that matter. We'll go to main.go and see how this comes together. You can see how the background and the egg file have been bundled using the embed package, and we set up our application here as normal. These 3 lines basically configure all of the graphical elements. We're loading an image for the background, a canvas image for the egg itself, and an item I've called T here, which is just a raster that's going to show the pixels inside the display. We'll look at draw in a moment. After that, there are 3 buttons. These are custom buttons, which I'll show you as well. Like I said before, they're not wired in, but they will print out tap A, B, and C for debugging. The screen is set to a pixel version of scaling, so it always looks crisp on screen. And then we package it all into one window. We stack, that is, layer things on top. The background, the screen, which is laid out using a custom layout, the eggshell, and then we put the buttons over the top with another custom layout. And then there's just this little tick here that loads different pixels. The egg is down and the egg is up, and we just refresh that raster each time it changes. That's really it for the application. We set its size and we show it. So let's go and look at some of the details there. The screen is perhaps most curious, so let's have a look at the draw functionality. You can see the pixels here are just a copy of an initial state, which I'm setting to the down state of the egg initially. The image that we're going to draw into is a very simple 32 by 16 pixel image, and that's why the scale mode of pixel is important. So we're going to be growing it into the available space we want it to look crisp. The draw function is the only other thing in this screen file. Being a raster, we need a generator function to tell it how to draw the pixels. And this is doing just a little bit of maths that detects whether or not a pixel should be on or off. If it's off, we color it transparent. And if it's on, we make it black with a very small amount of transparency to give it that LCD feel. And then we just set the pixels one by one and return that image. Pretty straightforward. I should look at the button as well. The custom button that I mentioned is relatively simple too. If you've ever built a custom widget in Fyne, then you'll see the button also has 2 states. There's the up and the down. That's when nobody's tapping it, and when it is being tapped. It's transparent when nobody's tapping it because we have the button image baked into the underlying egg picture. But when somebody taps it, we want to turn it a somewhat translucent white color to highlight it. The button is just a base widget. We have on tapped for the function that will be called, and we cache a circle for the rendering. We create the button, remembering to call extend base widget, and the main work is in tapped. So that's implementing the tappable interface. You can see that there in the Fyne definition. When this happens, we don't care where in the button it was tapped. We're just going to go, okay, so when that happens, we'll make it so that it appears tapped, the white color applies, we'll refresh it. Then we'll call the function that this has been attached. And then I use an animation from the canvas package to animate the color of the button, to take it from the foreground color, which you can see is the first into the transparent up version, and we do that over the standard short duration. And this function here just says what to do with the colour. We set it to the fill of the circle and refresh it again. And we start that animation, so you can see the buttons tap. The rest is straightforward to set the minimum size and return that circle as what's being rendered. In fact, the only complicated thing so far about this is really the layout. There's a button layout that positions the 3 buttons. Here you can see I've called them B1, 2 and 3. We pick them as object 0, 1 and 2 inside the layout function. I'll not step into the maths, but you can see it in the repository if you check out the code. We don't really need to do much. The min size here is just basically the same as what we wanted the application to be. And for the screen layout, we're just taking that one object and positioning it at exactly the right place in the center of our application. There you go. I suppose one detail I stepped over was the screen functionality. I said that there's different frames to describe the pixel states. This is a series of 16 integers. And what we're doing is for each row in the display, we're taking a 1 or a 0 for each of the possible 32 positions along the way. That just leads to this string of numbers, but it could be quite confusing. Let me just show you the application running again, and you'll see how this comes together. So you can see the different layers, and you can see the color when I tap the button. And the screen here is alternating between those 2 states, the up and the down. But how did I figure out the numbers for those pixels? Well, I have a little bit of a help here. I've made a utility for editing the screen pixels. If you check out the repository, you can use this too, but if I just go and run this utility, then you can see this area is editable with the pixels for the screen. I can make it bigger if I want to, and I've loaded it with a sort of crosshair so that you know where the center of the screen is. And I could then make whatever image I want out of the pixels, this little hat or arrow perhaps. And when I'm ready to use that, I just click this copy button. And that's going to copy into the clipboard the numbers. So I could then create a new frame and just paste it in. And you see how it's translated. There's a lot of zeros because we had quite a lot of white space or transparency at the top and the bottom. That one's probably not very useful. But let me just quickly show you the editor itself. That's the crosshair pattern that I showed you as it loading to start with. The application is super simple. We have a background color that's drawn using a rectangle and the toolbar which has that copy icon. When it's tapped, it sets the value of our pixels to the clipboard. This %#v is saying use the Go source code representation for this object or variable, and that is pix, which is this 16 length integer array. And then we just make the UI. I've got a thing called tapper, which we use to figure out what to do when it's tapped. And the content is just the bar at the top of our border, and the content is a stack with the background and the tapper on top. We're using the same image as in the main app for displaying what's being done. I've reused this draw functionality, but the tapper is where the change is. Each time it's tapped, this time we figure out the size of each cell by calculating how much of the available space would be used for each one, because it's resizable. And then we work out the X and the Y position by dividing the mouse position by that value. And with a little bit of maths and bit manipulation, we could turn that XY coordinate on and off inside the pixel array. And then we just refresh the screen with the change. The renderer for that is just another raster using the same draw function process, and we scale it using the pixels value again. That really is everything that there is to it. Thanks for joining me again. Do check out that Fyne Pet repository inside my GitHub organization. That's Andy, DOTXYZ. And check out other things I'm doing as well. Also, do read my blog if you would like to. It's at andy.xyz. And follow me on YouTube for an archive or on Patreon for other upcoming videos. If you'd like to sponsor me, that would be amazing. We have some stickers available, you can see there. And you can be involved in a conversation about what we do in the future on this channel. And if you're interested in building fine apps, but you're not a coder, consider checking out apptricks.ai, where we make this possible for people without technical skills and even accelerate developers who are unfamiliar with graphical applications. Have a great week, and I'll see you next time.